First problem is other indeterminate forms. So in this problem, we apply L'Hopital's rule if necessary. So we have limit of e to the power of x over x to the power of 4 as x approaches to infinity. First, we substitute the value of x. So we have limit of e to the power of x over x to the power of 4 as x approaches to infinity is equal to e to the power of infinity over infinity to the power of 4. So equal to infinity over infinity. So we apply L'Hopital's rule. So we have next limit of e to the power of x over x to the power of 4 as x approaches to theta. So mahimo na siyang pag-derive. Mahimo na siyang limit of e to the power of x over 4x cube as x approaches to infinity. So equal to e to the power of infinity over 4 infinity to the power of 3. So equal to t gihapon. So apply L'Hopital's rule again. So next is limit of e to the power of x over 4x cube as x approaches to infinity. So derive, so mahimo na siya nga limit of e to the power of x over 12x squared as x approaches to infinity. So substitute the value of x. So we have e to the power of infinity over 12 infinity squared. So is equal to infinity over infinity. So we use L'Hopital's rule again. So next is of e to the power of x over 12x squared as x approaches to infinity. So derive, mahimo na siya nga limit of e to the power of x over 24x as x approaches infinity. So is equal to, substitute the value of x. We have e to the power of infinity over 24 infinity is equal to infinity over infinity gihapon. So L'Hopital's rule again. So next, mahimo na siya nga ang limit of e to the power of x over 24x as x approaches to infinity. Derive, so mahimo na siya nga limit of e to the power of x over 24 as x approaches to infinity, and substitute the value of x. Then mahimo na siya nga infinity over 24. So any value nga over infinity is mahimo na siya nga infinity. So the limit of e to the power of x over x to the power of 4 as x approaches to infinity is equal to infinity. Next is improper integral with infinite limit of integration. So we have integral of sine x over 2 dx, boundaries of 0 to infinity. So solution, so an integral of sine x over 2 dx with boundaries of 0 to infinity is equal to limit of integral of sine x over 2 dx with boundary of 0 to b as b approaches to infinity. So we let u use substitution. So let u is equal to x over 2 and x is equal to 2u and dx is 2 du. So mahimo na siya nga limit of integral of sine u times 2 du with boundaries of 0 to b over 2 as b approaches to infinity. So next is ato pagawas ang constant. So mahimo na siya nga limit of 2 integral of sine u du as b approaches to infinity. Next is we integrate. We integrate. So mahimo na siya nga limit of 2 applied to negative. Ang integrate integral sa sine is negative cosine, then u, then b over 2 and 0. The next is we substitute the value of the boundaries. So naman siyang limit of 2 multiplied to negative cosine b over 2 plus cosine 0 as b approaches to infinity. The next is we simplify. So limit naman siyang limit of 2 multiplied to 1. The value of cosine 0 is 1. Then subtract the cosine b over 2 as b approaches to infinity. Since cosine b over 2 oscillates between negative 1 and 1 as b approaches to infinity, this limit does not exist, so the integral is divergent. And lastly, we have other improper integrals. So we have integral of secant theta d theta with boundaries of 0 to pi over 2. So this problem is discontinuity at theta is equal to pi over 2. So integral of secant theta d theta with boundaries of 0 pi over 2 is equal to limit of secant theta d theta 0 to b as b approaches 2 pi over 2 negative. So next is we integrate. So may man siyang limit of integral of secant theta is equal to ln secant theta plus tangent theta with boundaries of 0 to b as b approaches 2 pi over 2. Next is we substitute the boundaries. So may mo na siyang limit of ln secant b plus tangent b minus ln secant 0 plus tangent 0. Next is we simplify. So may mo siyang limit of ln secant b plus tangent b minus ln 1 plus 0. So secant 0 is equal to 1, then plus 0 tangent 0 is 0. Next is may mo siyang limit of ln secant b plus tangent b minus 0 because ln 1 is 0. Then as b approaches to pi over 2, both secant b approaches to infinity and tangent b approaches to infinity. So ln secant b plus tangent b is equal to ln infinity. So the limit is infinity, therefore the improper integral is divergent.